Triple C. Very nice. Music while you work.
Good afternoon, everyone, and welcome to week 6 and topic 6, coincidentally. So, today we're going to go in a little bit more closely into classes and objects, and we've moved to IntelliJ, and naturally some people are finding the transition a little bit tricky. The good news is it is tricky, so you're not imagining it, and I have seen from some of your kind of comments that you were struggling, but it's okay, or you're getting into it and so on. I suppose the reason we're doing it in this order is to give you a little bit of, the processing is so much easier to work with in one way, but it's completely limited. So what we're trying to do is just trying to get you started with something simple, and now making what is a big jump. So just to note that it is a big jump. So I'll just go from here, and so we'll just... So today, right, I just want to run through what we've done. So last day, Siobhan went through basically IntelliJ. So we said goodbye to processing, and that's processing, saying goodbye to processing, and we have moved into what we call a proper JDK, so which is IntelliJ. So yes, it's a big step up, but it will give you a lot more help. So processing is gone, IntelliJ is, and it's the IDE. And then Siobhan went through. We had the setup and draw in processing, and if you had those in, that's what managed everything. Because you always need somewhere to start. So in normal Java, if you like, when there's no kind of envelope around it or wrapping around it, you will need a main function, what we call a main function. Even though it's a method, we traditionally would have called it a main function, but there's other reasons for that. So we're going to look at that, and then because we need to be able to talk, to the outside world. Specifically, we need to be able to read in values, and generally from the default one is to bring it in from the keyboard. So we're going to look at the scanner class. So Siobhan went through all of that and then started on classes, objects and methods. So I suppose in one way there was enough to be getting on with starting with IntelliJ, and we kind of put in a little bit of the classes because we are starting to do them at the same time, but there was other exercises that didn't need classes as well. So today I'm just going to, as a kind of response to people that were struggling with IntelliJ, I'm just going to run through IntelliJ again, and just to create a project and so on. And then we look at classes and the properties of classes, fields, variables and attributes, methods and dot operator, and then later we'll create our own bank account, and we'll start looking at all those. So constructors, then what does that mean? You'll know hopefully by the end of the class, with a few intricacies there. Okay, so actually this is, yeah, that's more like it there. Okay. So 1, 2, 3, we're ready to go. But before we do that, I'm just going to move over to my laptop and show you the IntelliJ. So I will... Okay. So I'm just going to open one I looked at earlier, and we'll make that big. And okay, so you can see here, right, this is when I create a new, so I'll create a new one kind of in parallel, so I can say I'm creating a new project like that. And there's a few things here, right? It's really important that you get the location right. I'm just leaving it as desktop just so that it's kind of handier for you, really. Just give me a moment so I can see myself here. Okay, so I'm just leaving it at desktop. Now, Untitled 1, I'm just going to call this demo. Okay, demo class. And if I do that, and I'll say add sample code, I can either do that and that'll do that. So I'm going to say a new window. I want 2 windows going on at this time. Okay, so it kind of helps you out here. So you can see there the demo, and this .idea, it's the library and the settings for your version of the IDE. That's what that means. And you'll always have one of those in a project that looks like this. The .gitignore, it's all set up for Git, so gitignore, .gitignore we'll see kind of later, but basically it means if there's anything you don't want to be pushing and thing, and if you're not into GitHub, don't worry, you don't need to do that yet. Plenty of time for that. So where you have your what you want to see is in source. Now, I've just a few things that you've only realized when you're actually starting to get into things are, and that's the way, that's the way things are, right? So you can see here that the main, I'll just put on this. Yeah, so you can see there the name of the file is main.java. That's a Java file, and the class must be the same name. Okay, so that's a class that we will have seen. Now you might say, well, that's just a main. It doesn't get the full go of a class. It's not a class in nature, but we need to have, that's the way we need to structure everything in Java from now on. So this is just a main function that just prints out things. So if I here, I can either run, as I say, the project, or I can just say run main menu, or sorry, the main method. And if I do that, you will see that it comes up with, and that will have come from your arrays. So that's just generated code that you're looking at. Now, you can see here, if I deliberately make an error there, okay, you can see straight away that over here there's a red underline, okay, and now it means that you can't, if you try to run that now, it will give you this error down here, okay. Now, strange things happen if, for instance, you get rid of just put that back in there, and you get rid of that. It's not doing it now, but you can get all sorts of issues, and you can have a main within a main and all that, and that's really annoying. Like it can get very annoying, but just when you go in here, and just remember as well, this is similar to processing. If you click, a lot of the times it's going to be mismatched brackets, right? So you can see there that matches with this. So if you go down to here, you're saying, well, that matches with this. But remember, we have to have something that matches with the main one. So I just need an extra curly bracket there, curly brace. And now I can run it again. So you can see the errors don't disappear. They're there from the last time. So you can do that. Okay. So, okay. So I'll just hold that a minute and I'll see if there's any quick questions coming in. So my Wi-Fi is not doing great. Okay, so okay. Okay, so that's okay. Now I'll go back to my laptop. Now another thing that you will find very useful here, and okay, so I've created another one. I always wanted to say one I created earlier. Now I'm saying it. So I have a thing called test project there. And you can see here, we'll be looking at this later, but you can see here the way I have X, Y, and name. I just picked the name of the class of product, and you can see it over here, and I've just picked these. Now I can actually right click on that, and I can say, I can generate loads of things, but if I go down here, I can say generate, constructor, getter, setter, all sorts of things that we'll see later today. So even though it is a big jump, one of the reasons it's a big jump is because it gives you so much extra. I suppose the best thing that it does is with the dot operator that we'll be talking about later. Right, so we'll get going on this one here. Okay. So classes and objects. Some of this is a recap from what Siobhan did with you last week, and some is going on to new things. So we're looking at classes and objects. Then we're going to look at properties. So the two things that we associate with the class, we have data and we have methods that work on that data, be it changing, reading, and so on. So that should be number 3 there. Okay, so classes and objects we're going to look at first. And okay, so the example you would have seen would be string. When I say you would have seen, you would have used string, and in your last assignment, still string is still the same thing. It's still coming from the same place. So you can see here string, and there's loads of methods associated with that. Now, because you're a user of string, it is basically none of your business how those work. So remember, we have 2 really, really important words in any kind of design. It's how and what. Okay, it's called an interface, an application interface. It's telling us what the functions do. We don't care about how it works. It's like driving a car. You don't need to know how the engine works, but somebody needs to know how the engine works. And when they've done all that, they're going to produce like a user manual, and you can see this as a user manual telling you how all of these work. Okay, so when we're writing our own classes, we need to do both. We need to decide what is the interface, or how do people use our methods, but also how do they. So this is what we call an API, or an application programmer's interface. So that basically it's user manual for the buttons we want to use, or the methods we want to use. And then later, when we're writing our own, we need to decide how we're actually going to do that. Okay, so So an object is an instance of a class. So we're going to look at this, that an object is created from a class. And what do we mean by that? If we have a string, okay, we have a string and we want the string to contain we want to have hello in the string. Now, one of the issues with, if you have an integer, you always know how many bytes it's going to be. You're not sure how many bytes or how many contiguous areas in memory you need. So what the kind of halfway house is, what we give in an object table here, what we have is the address of the first element of the string, and that's the way it's managed. So then we can add that on and so on. So just say that's your address. We always pick this kind of FFCC. It happens to be in hex, which means it's just base 16. It's just a form of address. So just think of that as an address, a unique address in memory. Okay, so a class is like a blueprint for a building. So there's a very famous thing in the 70s when people were designing their own houses, and in the 1970s, I suppose I should mention the century as well. And there were so many people building things. Somebody somewhere decided that they would publish a book where about, I think it was 10 designs of, I think it was all bungalows at the time. Basically, whatever you were, whatever house you were designing or building, you could pick one of those. All right. And so the builder here wants to sell a whole estate of these types of houses. So the houses kind of, they will have different addresses, right? But they will all have the same basic shape. They might be painted differently. They might have different kinds of windows, but they're basically the same shape. All right. Now, just another thing as well, right? If any of you have been trying to keep a toddler happy or busy, and you bring them, you don't send them out to play with the traffic, but you kind of, if you're showing a small child cars, right, and you say to them, that's a car, and a red Polo goes by. The next time a blue Polo goes by, and the child very quickly will pick up that they're both cars, right? And then a Kia goes by. It's quite different in a lot of ways, but it's still, it still has four wheels. It still looks like a car. And all the way through, right? So you can have different colour cars, you can have different shape cars and so on. But if a lorry or a truck goes by, that child would be saying, they might say, is that a car? But they will check because it looks different. It has different number of wheels and so on. So it's a very different kind of animal. So what I'm saying is that I suppose what I feel is that the object-oriented is relatively new thing, whereas in fact it's so much based on the way we learn. We learn things by groups, okay? So in that idea, like, you have your car, so a bike comes by and there's still people moving on it, but the child will know this is not a car, right? This is not a car. So just to think of the ideas like that. So indeed we have a car here, and I'm calling this a template of a car now. It may not be the most fantastic template of a car, but it'll do. So we have a car, and somebody's decided any car in the world, it's going to have certain properties, and we need to be able to do certain things on it. So we could go back. If somebody wants to create a new type of car, we could go back to the drawing board, but we don't do that. We kind of say, well, look, we know there's going to be like a front seat and a back seat. Maybe there'd be 3 seats, maybe there's a people carrier in it, but we know the rough shape of it. And what we want to do is to make a general shape that's reusable in so many different ways. So, this is one car that's based on that template. Love that car. It looks great, right? I wouldn't say it goes very fast, but you can see it's a very early car, but a lot of the same things. So you can take loads of them. That's a BMW. I had to put that in, just in case. Morris Minor, the end of the And there we have our little yellow car again. And if I look out here from, in the unlikely event that there was a window here, we're working from the pods, but this car park is, you could see it as a collection of these car objects, and they all kind of have the same idea. They're all some form of these, and more importantly, some form of that. Okay, so that's the whole idea. And the basic thing is you have one class. So what we do is we generalize as much as we can. We say, what do we need to know about a car to be able to, because we don't want to be saying it is a car, but oh, I forgot in the general one, I actually need the number of doors, or I need the chassis number. So I put in as much data as I can on it. Okay, so there we have the car park, or the collection of all these objects. Now, the thing about the collection is you need to be able to access each one of those cars. So in some way, in the same way as we had arrays up to this, we need to be able to, you know, have a name on the BMW. We might call it blue BMW, or black Morris Minor, or I think that's an Austin, isn't it? So whichever it is, we might have names on this, or we might have a name of a collection or an array for this. Okay. And the main thing is, it's one class, many objects. Okay. Each object must have a unique name within the program. We need to be able to access it. If you don't have a name for it, you can't access it unless it's in a collection, and it's no use to you then. You can't do that. Okay. So oops, I'm back, here I am. And so we need to be able to access each of the objects. Now, in another way of thinking about things, we would have what we call a unique identifier. We're not dealing with the uniqueness of the identifier, but any of you that know a little bit about cars would know that the chassis number is a unique identifier, you would hope, and that also you could say the same about a reg number. The reg number comes after the chassis number, so you could kind of argue that. Okay, so it's really important to remember that now. So when you won't have to design a class for us for a while, but when you're thinking about designing a class, just think about the idea of the child. If you're trying to explain to a child what a car is, what is the general format of a house, that and just talk about maybe a two-story house, that there's a stairs there, there's a number of bedrooms that can change, all the things that are common about. Oh, I've doubled audio, have I? I think that's, yeah. Thanks a million for that. It's, hold on now, PC screen. Oh yeah, thanks. That's turned off now. Yeah, I had it on for the music. I hope you liked the music earlier. Thanks for that. So objects are typically related to real world artifacts. Remember the first time I saw these objects and you're kind of going, what thing? But if you describe a system, and you just describe it, writing it down narrative, any of your nouns are a candidate for being an object. Okay, so if you're talking about, I want to build a car. I want the car to be able to have different chassis number, different reg number. But they all have to have those. They all have to have an engine size, an engine type, but they can be different or the same, and so on. And just think about all of those things. You won't have to do, but think of the nouns, all right, the names of the bits in it. You might say they have a different kind of steering wheel. Is that big enough to be an object? And then you kind of start thinking, you're going, not really. I'm just going to describe that as a string. Okay, so we'll see that as well. So in object-oriented programming, you model an object by grouping together related methods and fields. So basically, right, you want to be able to do things like you want to be able to see what the chassis number is. You want to be able to change the steering wheel type, for instance, right? If you need to change those values, you need to have the values there. And we call these fields or the variables. So anything, just say, if you have a field in a class that there's no methods about, that aren't telling, maybe you don't need that field. If you have methods that are never called, maybe you don't need that method. Okay, so it's about this whole idea of everything you want to know about a car, you put in that class. Okay, for this system. Like you might say, I'd like to know what kind of a seats are in it, seat covers. Just say the ones you buy, you might buy them from Amazon and you put them on the seats. I don't care about that because that's not what the person selling the first car will have. Okay, so even though that might be information, it's not for this kind of car information that we have. Right, so we look at other objects and we'll say, here we are, we have an apple. So the kind of things we have need to know about an apple is we want to know the colour and the weight. Well, you might say, what about the brand or whatever, the make of the apple? Make is not the right word, but you know what I mean. So things that we might want to look at there, some operations or methods, right? Grow, fall and rot. What do we mean by that? If an apple is growing, right, the weight will change and so will the colour in a lot of cases, right? The fall will happen when the weight is above a certain weight, okay? And the rot then will change. So the fall happens, but the rot will change the weight and the colour as well, okay? So you can see, because it has to fall before it rots and so on. So you can see there's things associated with everything like that. And I'm saying to you for this, that's enough for what we need. I don't need any more fields for that. Okay, butterfly, species and gender. I need to know maybe the species and gender here to know how they grow, flap wings or land. The radio, for any of you that know the physics of this, you'll know that the frequency is how you tune in radios and the volume is how, well, you know how the volume works. So the sort of things you need to be able to do with this radio. Now, we're not going to be programming this. It's just a real life. You need to be able to turn it on, to tune it, which means changing the frequency. And you want to set the volume, which means changing the volume. Okay? So the turn on is kind of like creating the instance of it, if you like, even though you may have a physical lovely radio in your kitchen, but you know what I mean. Here's my car. It's I've gone for a very cool car there, I don't think. So in the car, you might have to make the model, the colour and the year. Now, obviously, there's a lot more that I could say about a car. And one of the methods then would be to change the colour, because the colour isn't a fixed thing in a car. And especially if you're producing 50,000 cars a year, they're not all going to be yellow, you would hope. So, returning to the apple example, right? This is our object type. It's called apple. So we can have many objects of type apple. In the same way as when we have string, we can say str1 is of type string, str2 is of type string. These are our fields or our properties. Now the whole point of those is, and we call them variables for a good name, we can change them. We don't have to, but we can change them. We can use them. We would expect that they will change over the time of the object. Because if not, we can call them a constant, so there's things like that. And these are the methods or behaviours. What we mean by they're implemented as methods, but you can think of them as the behaviours. How do the data change or how does it get displayed? So it's the behaviour of the data that you need to keep about a about you need to keep the colour and the weight. You don't necessarily have to keep as data the current temperature, because that'd be very expensive, right? So what you would tend to have is the grow that you'd have input for maybe temperature and moisture. So you're saying, given this temperature and given this moisture, and I know the colour and the weight because I have this in the object, tell me how that changes the colour and the weight. So it can increase the weight field and maybe even the colour as well. The fall will probably do something like continually check the weight. Now I said if it doesn't change any of them, but this is actually reading the values and doing something with it. So and don't worry about how we keep checking that, it's just the idea for the moment. The rot then takes over and it begins to decrease the value in the weight field and change the colour. You might need some inputs there. Maybe the temperature has a lot to do with how quickly it rots and so on. So, but you can decide on that later. But again, there's no point in having the temperature as a variable, because you would need to keep updating it. You could, if that was suitable, but you could also have a method that takes values in from the outside. So from that point of view, you can have data, which are what we call the state data. So an object has an object state, which is, if you like, a snapshot of the values of those data. And then you can also have inputs from the outside, sensors, anything like that. And they're the two pieces of data that you work with, and you can either report on those or change the values based on that. Okay, so we saw the last day that an object is instantiated from a class. So we have our template of a car and we can create loads of cars from it. One class, many objects. Just keep thinking about that. It's one class, many objects. And each object, when I say it has to have a unique name, it has to be uniquely accessible. So when we talk about arrays of objects, as we will, they're all uniquely accessible, because you can just say the array square bracket I or whatever. Or a name for the yellow car, or the lovely little black Morris Minor. And okay, so for the Apple objects here, this is our class, so we just one of them. And remember, we said that this was our object type, these were our fields, and these were the methods or the behaviors. So here, now these are just graphic pictures of what they might look. So I have one and it's called Gala. Now that's not a field, that's my unique name for it. And in this case, the colour is red because Gala apples are red, and the weight is 6.2 grams. The next one is Golden Delicious. Now you might say, oh, there's a lot of Golden Delicious. Yeah, but I only have 2 apples, so I'm using these names. And the colour is yellow and the weight is 8.4. Now what type is colour? That's a different matter. We're just saying it's this type at the moment, and we're kind of not worrying about that because we're not going to be programming an apple. Okay, and so 2 objects, each of them has a unique name and its own copy of the fields. So we've 2 fields there. If we've 2 objects, we now have kind of 2 multiplied by 2. So it's storage, and that's why I just say for the temperature, if you don't need to store something, don't, because you're dragging it around with you all the time. Okay, so there's 2 types, 2 objects of type Apple. Each has a unique name, Gala and Golden Delicious. It is a different object state. So that means it has its own copy of the fields. It could coincidentally contain the same values, but that's a different matter. It doesn't have to be the same values, and they can be different. So each object has its own data stored in these fields, and in fact it has a copy of the method as well, but more on that. Okay, so the colour and weight and the data is stored in that. Okay, so the object state, this is why we have the fields in there. At any time we can what we call interrogate or change the values of those variables, as we call them fields. Okay, so the dot operator, what's that, right? Now, if we have two different objects of the same type and we want to get one of their colour or weight, we need to be able to indicate which one of the objects I'm talking about, because colour is not unique, because there's two colours there. There's one for Gala and one for Golden Delicious. So this is where the dot operator comes in, and we call them external calls, but you'll see what we mean by that in a moment. We have an object, and remember that could be Gala, and we can say dot property, which we can say dot colour, or dot method, so dot grow as well. So just say Golden Delicious dot colour. That gives us access to the colour value in the Golden Delicious objects. That is dangerous, so I'm putting that in with kind of a warning. The grow here runs the grow method inside the Gala object, so that is going to, you expect, possibly change the weight and the colour. And Golden Delicious is fall, so you're saying, so sorry, they're the two different objects with different, same field, but will have different values. Here, the methods will have a different effect because they're acting on using different values, and the same with fall. Okay, and that's that. Now, what I'll do is I'll take 5 minutes, and we'll come back. So I'm going to put on some nice music for you and a timer, and we'll be back in a while. Okay. Is it working?
Somebody has a router somewhere close.
Hi, welcome back. And what we're going to look at now is we're going to take kind of an idea, and we're going to use the idea of a bank account, and we're going to use that as our class, our object, and we're going to do it first of all without classes, and then we're going to design a class that shows you what the benefits are. And hopefully you'll bear with us, because it takes a while to have enough working with it so that we can actually get the benefits of the object oriented, and that'll probably be next week before you can see that. Okay, so I'm going to go on here, and you should. Okay, so first thing we're going to do is we're going to create this bank account, and sorry, just give me a moment there. Okay. And so we're going to use this to kind of illustrate all what we've been doing. So we're going to start without classes, and we're going to say, how would we do this if we didn't have classes? Then we're going to build it up. Okay, so we're going to just create a bank account, and deposits money, withdraws money, and prints out the balance. And then we'll refactor it by writing a class, and you can see the benefits, hopefully, of the class then. Right, so here is our first version of it, and you can see here we have our we have our main function, and we're going to do everything in the main function here because we don't have classes yet. Okay, so this is our main function, and I need to make it a bit smaller there. And so we have our Joe Bloggs is the owner. We have an account number and we have a balance in there. So if we want to deposit money, right, we're going to do something like this. We're going to say we have a thing called deposit amount, and we're going to add that balance account. We're going to end up with these values up here as our fields, but not yet. They're just all variables, okay? Because we haven't got into the class yet. So we're just going to, what do you want to do when you want to deposit? Well, you want to add something to your balance, and the amount that you're putting in, we're hard coding it here now because we don't have another way of getting it in at the moment. Okay, we kind of do, but we're not using it. So the next one then is withdraw. So you're saying, can I withdraw 200? Now the first thing with that is we're still going to try and stay safe, right? So we're going to say, well, this is not an overdraft facility, so if the balance is greater than or equal to, so if we have enough to do that, we'll say take that amount away from the balance, and then otherwise you say unable to withdraw due to insufficient funds. And then at the end of that, you just say name, account number, and the new balance. Okay, so make sure you're okay with the kind of the functionality of that before we go restructuring. So we have that, and we expect, apologies, I should have updated the reference. The name is, that should be Joe Bloggs, sorry. The account number 123456, and the double balance here, that's just an old, sorry, I'll update that later. That should read out Joe Bloggs, that's the account number, and that's the balance. So that's all very well, but what if we want more than one account? We need 3 bank accounts. All accounts would have the same set of variables. So you can see it's going back to the child looking at the cars. They all look the same. So they all have the same behaviour. We'd have to check, is there enough there to you know, if we were drawing to see is there enough. But all would need to be completely rewritten with different variable names, because, you know, you'd have your account number 1, account number 2, different method names, because again, you have to have a unique, and so on. So we need something else, and guess what? That's where classes come in. So the first class creates a unique data type. So what do you want the code to do? What are your attributes? Fields. What's the data you need to hold on to? What methods do you need to be able to manipulate that data or report on the data in a way that's appropriate to the system you're trying to write? So first of all, we list the attributes and figure out what data type they should be. So here, as I said in the last one, right, if we have that in a kind of an awful kind of old-fashioned way of doing it, these are the pieces of data that we actually use, because we use all of those. We use the Joe Bloggs to print out, even though it comes out miraculously as Elon Musk. And so you can see that's all of them are being used. Some of them are being changed. Okay. So the required fields are, we need the name, and we're going to call that a string. We need the account number to be a string as well. Now you could argue that that could be a number, but we could get very kind of philosophical about that. You don't really use an account number as a number, if you like. It's a unique identifier, but you never add one onto it. You never subtract numbers from it. So if you like, we don't use it as a number, and that comes into it when we're trying to type it. Balance, absolutely, we take stuff from it, usually sometimes more than we put in. But enough about me, this is about you. Creating your first class, we give our new class a name, okay? So the name can be any word or words. Really important, right? The name, any variable we've been talking about before, give it a good name. Make it a present to your future self so that you know what's going on. It's the same with the class. So it can be any word or combination of. It should begin with a capital letter. It will compile if you don't do this, but what I need to be able to see later, I as a programmer, you as a programmer, you need to be able to see when you're typing things. When I mean by typing, you're giving something a type, whether it's this object type or a primitive type, and the capital letter, it allows us to distinguish that or between those very easily. So go with the conventions because they're there for a good reason and they make things easier. What we're always trying to do is have a few rules so that you don't have to make decisions every time you're going, it's a class, so it starts with a capital letter. It shouldn't be pluralised because an object is everything you want to do about one of the nouns. So one bank account. I'm not worried about many bank accounts at the moment. I've enough to be getting on with. We call this, I love this word, right? We call this word, where do I have the text now? We call it separation Okay, it's separation. Oh yeah, I can write it here. Sorry, excuse me. Separation of concerns. All right. So when you're writing an object, just concentrate. What are the things that every bank account needs? One, right? So if you were to write it just one, that's kind of reusable, what would you do? You've enough to worry about what you do with a collection. That's a different issue, okay? And the thing about the separation of concerns is you concentrate on little bits at a time, and that's great. And that's the way divide and conquer, it's another way of putting it. So we could have a bank account, that's what we're going to look at. You could have an object called student. So student is all about one student. So things like your student number, your CEO points, that's not just say relevant to everyone. It wouldn't be relevant to you, for instance, in some cases. Just give me a moment there. There might be an issue here. I don't know. Just back in a moment. All okay?
Yeah, okay.
Sorry. All is okay. I had to contact my employer, Siobhan. Tell me everything's okay. So the student, everything you need to know about a student. So things like your address. So that might change. So you need a method to be able to change the address. You might have an average mark or a suite of marks. They will change at the end of a semester. All those sort of things. Product. And then, with the student, you'll have a class full of students. But that's a different matter. We'll get onto that later. Plenty later. And the same with product. You have one product, what you want to know about it, the name of the product, the unit, the ID, the unique ID, the unit cost, the price, any things that you need to know about every product. Okay. So we're going to call the first one a bank account, because that's the way we are. We're going to use the first one, which is here. So we have a bank account. So the first thing we do is we create the bank account we create the bank account object by doing this. Now this new thing, the new thing here, what that does is it creates the bank account over here called bank account 1. All right, and it gives it a space in memory. I always write objects as kind of blobs like that, okay? And then it puts into name, it puts in Joe Bloggs. We're going to have nicer ways of doing this later, but we can do it like this as well. We can have account number as 1, 2, 3, 4, 5. And the balance as 1,500. Yep, okay. So that's our, that's one of our, the bank account 1. So then in the next one, we're doing this is awful code, right? So we're just showing you. So we have a new variable. We're just bringing in a new variable because it's only a main function. We're not interested in reading it in. We could, of course, but we're not going to bother at this stage. So again, what you're doing here is, remember the dot product? You're saying that's the balance. Take that value, and remember the way the assignment statement works. Sorry, this is the balance here. And take, so deposit balance now is equal to plus, sorry, that's the deposit, plus equals to 300. So that's going to put 1,800 in there. Yeah. So now that's 1,800. The new value is 1,800. Okay, and the next thing then we want to withdraw 200. So you're saying, in this case here, you're saying if there's enough in it, we're going to go balance minus equals 200. So you want to get 1,800 in there. So we'll just go and 600 in there, 1,600. Okay. And then at the end, we're going to print out name, Joe Bloggs, one, two, three, four, five. Sorry, that should be account number there. Yeah, so you would do something like this. And then balance. Okay, so I'm just going to disappear there so you can see that there. All right, so that's what happens here from here. Okay, so we're getting there. The big new thing here is our use of the dot product. So we're saying we have one, now we're going to use that. Okay, so we can only do this because we have a class called bank account, and it has 3 fields in it: name, account number, and balance. Okay, and we're going to look a little bit more at this then. This is defining the class. Now, the other side of this is in IntelliJ, I need to create a new class in Java. Declaring the fields in the class, And you can see that there. Okay, so just bear with me there for a moment. And so I'm just going to go onto the laptop to show you this. So we're in here. So I'm just going to create a new project, and I'm going to say it's going to be bank account. All right, there's a little bit of a create, and it's on the desktop. It shouldn't be, but I'm just leaving it there for the moment. So I'm going to put it into a new window because I just want to. Okay, so you can see there I accidentally put in the main program there, but I can get rid of that anyway. So I'm going to make a new class, and I'm just going to call it bank account. I don't have to worry about what the extension is. And you can see there it comes up with nothing. So my first thing to do is to put in my string name, string account number, and double balance. Okay, so now a few things there with the, actually sorry, I'll just change the settings slightly there. Okay, so you can see that a bit better. So you can see there, they're all grayed out, those ones, the name and the thing, because nothing is using it yet. Okay, and there's nothing we can do. But you can see here, that's bankaccount.java. All right, so that's the name of the file, even though you only put in bank account. And you can see over here, it's saying it's a class and it's called bank account. All right, so we'll go back to our screen. And this is our version 1 with that bank account. We're declaring an object of type bank account. The new, as I said, actually instantiates so it actually makes it in memory. And then it can put these values into it. Now, kind of enjoy enjoy the way you can do that, because it's not going to last for too long. This is very nice and easy, but it's actually really dangerous as well. So we're not going to be accessing the fields directly like this from today on. But just that's what you're actually doing. You will be able to access methods always, but not fields. We're going to set that up. Okay. You can say you're calling the bank account constructor. So a constructor creates space for the object in memory. These are initializing the variables. We're going to do that in a lot more elegant way in a while. Okay, and with draw, we're going to do that with a bit of validation around it. And then we print out the values. Okay, so you can see what's going and the order of things there. Okay, so the constructors then, the default constructor is what we use there, right? When we said new bank account, Java is very nice to us, and it actually gives us a default constructor that just says, look, I'll give it a memory and a memory location, but I'm not going to put any values in it. But what I put in it are the default values. So a string, the default is null. Null is a special value that says there is no value here. It's the initial value. For integers, it's 0. For double, it's 0 as well. So if it'll put the default values in. never depend on default values, but at least they're there. Okay, so we're looking at constructors, and the first one is, as I said, if we just say bank account here, null means that there is no address on it. We don't know where it is yet because it has no memory associated with it. It's just an idea yet. It's a box waiting for the memory to be allocated to it. So it's initialized to null, which means there's no memory. Null is the computing version of 0, the address version of 0, no address. So here then, when I say new bank account, and when I put the values in, now they didn't go in by default. We put them in by using the dot operator, and we put those values in, and then that's what that ends up with. Okay. So the constructor just did this bit with empty fields here, so the name would have been, and so on. Okay. So here, it's constructed with the new. The new is a really, really important word. It's a reserved word, which means you can't redefine it. And the brackets here means that it's a method. So what do we mean by a method? Anytime, syntactically, the difference between a variable and a method is those brackets, actually. So this calls a method, and you're kind of going, well, I haven't written any methods in there. So it's the default bank account. Don't worry, we'll be writing our own version in a minute. So it's the default constructor, and it builds in objects in memory. And that's what it looks like. Not in my head. That's what it looks like. It's actually just blank. So it creates the thing in memory, but it doesn't give it any explicit values. It holds its default values. It has, now a constructor is a method. You've been looking at methods all the time, right? What's different about a constructor? It is a method, but it's the only method that we'll be seeing that has no return type. Okay, and it has the same name as the class. So two things that are different about it: no return type, and it is the same. So you don't have to come up with a name for a constructor. It's the name of the class. Okay. So we're going to look at the default one first. So this is our default. We get this for nothing. You can also write it. You can put more things in it. If you don't include a constructor in your class, you won't see it in the code, but it's there in the background. Now you could actually code that yourself and just say put in name as, I don't know the name. You could put, you could put hard code into it as well if you wanted. So it simply constructs the objects and puts these values into it. Okay, so any object type, its default value is null. So remember, string is an object type, so that's null, null, and the balance is 0. Okay, so it's not brilliant, but at least it allows you to put the values in then. So in this code, we initialized, we did the constructor, and then we put values in it. Now, so the constructor there, right, it had no way of putting values in, so it had to use the default values. So how about if we looked at constructors that allowed parameters in? And this is where they get neat and elegant and so on. So this one here. So our first constructor, we're going to take 3 new parameters. This is for a name. The account number is for the account number in the balance. We're using different names. We'll get back to that eventually, but for the moment we're doing that. So these values will be initialized: name, account number, and balance. So you can see there's a connection there. So name is a value for name, account number is for that, and balance is balance. Okay. We'll come up with a nice way to do this later, but just to do it from first principles first. So here now, we were looking at this, but now we can do this. So we can take 3 parameters, So what does this do, right? So what this does is when we call this constructor, the value goes in as name, right? So we'll say if the name is Mairead. That goes in to name. The assignment says put into name whatever is here. So that's the field value. Same with the count number. I'll say 123. That goes in there. That goes in there. So name is Mairead. Count number is 123. And we'll say the balance is 100. So it only comes in because of the assignment, and then assignment, the assignment, and then balance is 100. Okay. And this is the way that constructor works. Okay, so make sure you're okay with that. All right, with the way that works. Now, so this is the way the new one is called because I have this extra one here. And you can see because, and remember, it is a bank, it is a constructor, so it still has the no return and the same name as the class. So you can call it here. And again, with all methods, the order is really, really important. Okay, so you have that, the count number is that, and the double balance is that. Okay, so that's going to have the same effect as the previous one. All right, so it ends up with our values on that. Okay, now what that was it was overloading a method, which you'll have seen before. So we now have two methods called bank account. So we didn't write this, but it's there. Okay, the first one, this one, number 1, and this is number 2. And how do we know which one to call? Because the number of parameters. So if we just say this one, it looks for one with 3 parameters, picks this up and runs with that. If we had said new bank account, it would go with this. So there always has to be a unique way of making that decision, or a non-ambiguous way of making that decision. Okay, so this is the default with no parameters, and that is the one with the parameters that we've seen. Okay, so that's the end of that one. I'll just take another 5 minutes and come back with more on that. Okay, thank you very much, and I will put on a bit of music. Hello, and we're still looking at the bank account, and just for you going through this, we have a recap of a lot of the concepts at the beginning of the lecture, but we've just done it, so I will be. I just want to remove that. It's a bit annoying there. Sorry. Okay, so if we look at classes, you can see we're just going to do, when I say very quick, I mean really quick, recap on classes and objects and the defaults. Just to put it in context for you, in case you're skipping over to just to this part. So, again, a class defines a group of related fields and methods about what we call an entity. All right, so it's like a student or a car, or in our case, a bank account. What's everything you need to know about a bank account, and what are all the things you'll want to do with a bank account? An object is a single instance of a class. So we've one class, but you can make as many objects as you want. We don't worry about kind of limits on machines. Conceptually, you can make as many as you want. Many objects can be constructed from that. And the analogy, a cake, if a class is like a recipe for a cake, the object is baked from the recipe, and you can bake loads of cakes. They might have different coloured icing, but they'll all, have the same idea. The class name, like naming, is something we can keep talking until we're blue in the face, but until you kind of buy into it, and I'm not saying you're not, like most of the variable names were good in the assignments, but just always, if you have a kind of a wishy-washy name for the class, it means you're not really sure what the purpose of the whole thing is, So if you can't describe it in one word, maybe it's not a class. So, Apple, we had bank account, student, any of those. So when somebody sees something of this type, it kind of they know what it's about. So we have our Apple. We had that, right? And I'm just going to run through that. The dot operator, remember, we used that to get into an object from the outside. And then we looked at creating, allocating memory for that object. And we did this by creating the bank account in IntelliJ. And then we had this where we changed it up, and this is version 1. So we just kind of set it up as a bank account, but we kind of didn't get any benefit from it. You'll see what I mean by that when we go further. And initializing the fields, and then we looked at using the dot product to actually change those fields, which, as I said, we'll deal with later, but you can see how we can do it now. So here, this is the way it's defaulted. If you're just using the empty one, it's constructed, but the new is the really, really important word to use, okay? And that's the one there, and there's nothing in it, but it does create the space in memory, and it defaults everything. So any object types like string, they'll go to null, and everything else will be the default of that type. So double has a default or integer of 0. Okay, so and then the num here and all that. So this is the new constructor where you're bringing in initial values for each of them, and it kind of it tidies it up, so you're actually bringing them all in outside. And remember, you'll be calling this from a different class in future, so it'll make more sense as well. So we call this overloading because we have bank account can be created in two ways. By both of them, their names are bank account because they always have to be the same name as the class, but they have different numbers of parameters, so it's easy to spot which one you need to use. And okay, so we're going to, so this is what we call the class diagram. What do we mean by that? Here we have the object, type and name. We have the fields or the attributes or the properties. I tend to use the term fields, and then here's our what we call the overloaded methods, because we have two constructors with different numbers or types of parameters. So we're going to look at this now. We're going to start adding the behavior. So one thing we'll kind of need from everything in class, there's no point in doing all this thing in a class, but we need to be in some way be able to report back on a kind of a snapshot of what's going on in the class at that time. So we're going to look at a display, and we're going to start with a very basic and kind of badly designed display and then make it a little bit better. Okay, so the first one, we have all these values. So we haven't defined any behaviours, only by creating it. And we want to do this as well because we want to be able to make the deposit or the withdraw safer. And to do this, we don't just do an assignment statement, we do checks and so on, and we can build that up. So basically, by removing the ability to directly put values into name, account number and balance, we keep them safer. But we'll be seeing more about that as well. Okay, so if we want to print the account details to the screen, we're going to make a method called display on console. Okay, so very simply, you're just going to print the details of the account. And this is a kind of a starting point for it. So you just print out the name. Now just be careful about what this does, right? You have your, remember we did this in the previous one, the name, the account number and the balance. So remember what we're doing here now. We're trying to write a class called bank account. And this is like a building block. So we have this now. The first thing is, and this is important, we're writing it inside. Okay, so look here, right? Everything between here and here is part of the bank account file. Everything between here and here is part of the main file. It's down a little bit there. Okay, so this method, display on console, is available through that. So the way we print it, we can just print it by saying bank account dot display on console, and that immediately does what it asks to do. It prints out the inside of the object. Okay. And you can see there, that's where it's called. But we want to make a new rule now. What we're going to do is, eventually, right, we'll have just say the main program. And what we're going to make is the rule that only, we're going to say that only the main can do I/O. In other words, reading in values, which we haven't dealt with yet, we're hard coding everything, reading in the values, but also printing. Why is this, right? We can see this as a building block here, right? If you look at the walls beside you, in our case here, there's no plaster on the walls, so you can actually see them. You have a block and you make a wall built up with loads of these blocks, right? You might use those blocks in different places and different times. What we're going to do, therefore, is we're going to say, we're going to leave it to the main program, whatever way it needs to be printed out. In this case, it's the console. That's just a little bit too specific. So what we do instead, right? And it's for a very good reason. We separate our concerns. We don't use print statements in anything else except the main. We're going to start calling the main program. We're going to start calling it the driver, which means it drives the rest of the program. Can make sense. But we don't use a print statement. Instead, I showed you that as a system out so that you could see what's been printed out. But what we're going to do is we're going to write a method that returns a string, and then the main or the driver class, whatever, can decide exactly how that is sent out. In our case, it's going to be to the console, so we don't get anything extra in it, but it makes it more reusable. So here, you can see here now instead, you can see that display. So the return here, the return there, returns that string. So what is it going to do here, right? So what is in there is the string name Joe Bloggs, account number, or sorry, Elon Musk, account number 1234567 and balance euro 1500, and that's going to print out that string. Okay, so convince yourself that you're happy enough with that, and you can see the benefit from it, because I could decide, some of you use JOption and so on. I could decide that I want to put that out in a window, and I only have to make that. I can say I can use bank account because I know it didn't make any of those decisions. So it's far more reusable like that. And we're going to take that approach right throughout. So now we have a display, and later on we'll kind of improve that so that you can see the return type, but there that is there. So if I want the next one, then we're going to have a deposit as well. So for the deposit, we're putting in a new method, right? And here we're taking in as a parameter the amount that we want lodged. Now we're just saying you can lodge as much. We don't have any limit on the amount you can lodge. It's a different story for withdraw. So we simply add the value of the lodgement to the balance. So you can see here that's going to change the value of this. Yep. Inside in the blob of the bank account, the particular bank account one. So you have your bank account one here. Whoops. Bank account one, I'll call it. And then your balance was 1500. And now just say if you call that there, that's going to upgrade or update that to 1800. Okay. In that case. So now we've deposit double, and you can see what we're doing here. We're bringing in so we can actually, and you can see that that's a lot more elegant, because if you call that a good name, deposit, which is a good name, it means you can say, I'm calling the deposit method. So I want to deposit 300 euros into this particular bank account. How do I know it's bank account one? Because I do bank account one dot, and that's where the dot comes in there. All right. And you can see there, we have the double there. We don't have to name those. You can if you want, but you just have to say what type it is. So you expect, by looking at that, you would say, I would expect that means that I'm depositing an amount which is given in as a double. Okay. Next one then, the withdrawal is slightly more complex, because for any of you that want to see this, you can see in the previous one, we checked that we had enough money to withdraw. Now we're not assuming anything about an overdraft at the moment. How do you know that? You know that because we don't have any data about the overdraft. Okay, so in this one, we want to take the parameter of the amount you wish to withdraw. We need to check, and this is why we get, and you'll see how it kind of cleans up the code, because we're going to encode all of this over in the bank account. If there's sufficient funds, deduct and return the string withdraw successful, and otherwise if there's not sufficient funds, you return a string that says this. So this is it, right? This is the string. So you've withdraw and you've double withdrawal. So that's the amount that you're sending in. All right. And then you're checking, as you would expect, you're checking the value of balance. Have we enough there? Is the balance more than the withdrawal? If that's the case. Now, what we're seeing here is, because we're being very particular that we can't, you know, before you would have just done a system out of println here. But now what we do is, we can change this return type, but at the moment we're going to send back a string to tell us whether it actually worked or not. Okay, so, and you can see the way this is called, and you see that the withdraw message, it goes back into withdraw message, and I can print that out there. I could directly say system.out.println and use that bit of it, but for the moment we'll leave it at that. Okay, and you're also now going to call the display, and you can see there the only system that out printlns are in the main program at this point. Okay, so you have, that's our new class diagram for bank account version 6, and then we have the this, and if you remember, we had this in our constructor where we have different names for the fields, and what we did was, so we said, oh Lord, we said here, the name comes in there, and we can see the difference in, so name comes in there and name then goes in there. Now this is the sort of thing we'll be doing all the time, okay, because, and one thing that all this reuse and everything like that, we like really concentrating on how good are the names, and if name is a good name, well, is there any way we could reuse it there? Okay, so we can't just say, we can't just call it name, right, here. Well, we can, but, and then say name is equal to name, because scope of variables. There's a rule, the golden rule of data. Use the most locally declared version of a variable. Okay, so what you get here when you do this is you actually declare and create a variable called nm, or in this case name. So when you go down here, okay, that'll go in no problem, but actually what happens is that the name here is the same name, because it says I have two names, I have this one and that one, but the most locally declared is just here. So all that does, it says name is equal to name. It doesn't change anything. So I want to get the best of both worlds here. I want to be able to use name, but distinguish between the name coming in and the name of the field. And I do this, it's name overloading. How do we distinguish? And we distinguish by using the this keyword. And in this case, these are the field names, and these are the local. Okay, so you can see there account number is in red. This account, that's the field. And you can see here, the name is in green. So that's the name that comes in. The account number, the red one, is the this because it's up here, and the this balance is there. So you can see that the local variables are destroyed as soon as the method is over, but the coloured fields stay. So to clarify, in this statement, this.x is equal to x refers to the object's property, this.x, and x. If you don't have an x defined in it, it'll also be the field, but in case where there's two, that's how it's distinguished. It's name overloading. Okay, so now we have version 7, and we have this. We didn't change the class name, we didn't change the class diagram because we didn't change any of what the methods did. What it does is it changes the way it actually is written, and it's a much nicer way to write it. And there we go. And that's it. So now I'm after going through an awful lot of stuff there, guys. And the reason I'm going through it all is because we have a bit to do on Wednesday. But I just want to not have that and the other stuff to do next Wednesday. So if you can, have a look at that before Wednesday and be ready to go. But it's now 2:00. Have a great 2 days before we see you again. Thanks to Siobhan on Slack. I didn't say thanks to Siobhan for slacking. Talk to you on Wednesday, and just keep using the Slack. You're using the Slack brilliantly, actually. So it's great to see that. All right. Thanks a million, folks, and talk to you soon.